see if the recording has started. Okay, great. So trying to understand how this, I explained in the last class how we can get this IP. You will be the one to decide whether you want to work with a private IP address range, or with a private IP address network, or with a public address network, right? So now from this 10.00, you already know that it looks like a what is it called? A private IP address network, right? And this has /16, right? I was explaining to him that whenever you see this /16, right, from what we learned in the last class, when you see /16, what it literally tells you is that the first two portions, remember this is 8, this is 8. So 8 plus 8 is 16. So these two portions of the network, this is the network portion, this is the host portion, okay? So if they ask you to, if this is the network IP given to you, network address given to you, and they ask you for the CIDR range, this is what the CIDR range looks like, okay? This is what the CIDR range looks like if you want to interpret this, okay? This is what the CIDR range looks like. So it is from 10.0.0.0 to what? 10.0.255.255. So these two host portion will be changing. It will not get to this point. If it tampers with this one, it's a different network entirely, different from this. I hope we get it. So if you get this first part, now the next question is this: how do you now break this into a subnet? Okay, how do you now break it down? Because I also established the fact that whenever you see /16, I told you that one of the octets is 8 bits, 8 bits, 8 bits, 8 bits. And we calculated that when we calculated the 8 bits, we were able to get 256. Is it not true? We calculated that each 8 bits can take about 256, which is from 0 to 255. That was what we calculated when we did 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2, and the rest of them. We're able to calculate that each octet can take about 256. You understand? Now, having understood that, so whenever I see a /16, so this tells me, because this is the network side and this is the host side, I have 256 here, I have 256 here. If you multiply 256 by 256, you're going to get 65,000 plus. Let's try to do the calculation. So let's see. So if I come here and say 256 multiplied by 256, this is what I get, 65,536. So that is the total number of IPs or hosts we can generate from here. If you come here and say IP calculator, okay, and I think you use this one. If you come here, remember, this is the IP range 10.0.0.0/16. If you come here and put, are you saying something? Let me know if you're saying something. 10.0.0.0.0. Okay, this is it. And you come here and you put /16. So if you come here and just click on calculate, right? If you watch here closely, you're going to see the address is this. And this is the subnet mask 255.255, and we have 0.0. I hope this makes sense to us. So this is the network, and this is the broadcast. You understand? So that was what I was telling you, from 10.00 to this. And if you check the host minimum, the minimum is this 10.0.0.1. Okay. After this network address, the next thing we have is 10.0.0.1. And the next thing we get is 10.0.255.254. I've already told you that 255 in this context is a broadcast address. Okay, so that's the reason why they are putting 254 here. So these are the usable IPs. So it's telling you the host minimum is this, the host maximum is this. So it's, if you add this 254 plus this, you see this is 255. This is 255. If you add this 0, 2, you understand? So in total is 256. So if you watch here, you're going to see that the total IPs here is 65,534. You understand? And when we did the calculation, what we got here is 65,536. So minus 2, which is the host address and the broadcast address, you will get 65,534. Is this confusing to anybody? Please let me know. So that's what I was trying to say here for this particular one. Okay, so if we say that this /16 is 65,000 plus, and that is for this VPC, right? If you want to break down your network, okay, maybe you want to break down the entire network into two halves, okay? That's the reason for subnet. When you hear the word subnet, it means sub network, okay? We are breaking the network further into 2 or 3 or 4, okay? You will be the one to decide. Nobody is going to tell you what to do, all right? Now, in this case, we assume we want to break the network into 2. So these are 2 subnets. Again, we are not talking about whether it's public or private. Every subnet is a subnet. What makes a subnet, whether it's public or private, is because of the rule you attach to it. So a public subnet can be converted to a private subnet, and a private subnet can be converted to a public subnet once you change the rules on the route table. Okay, I'm going to show you all those things, but I don't want to confuse you just yet. So this is what we have here: 10.0.1.0/24 and 10.0.2.0/24. Now, you may be wondering, if I decide to do this, right? This is 10.0.0.0/16. You understand? Now, and this is what I have here. I told you that /16 will give us 65,000. Is it not true? Now, but AWS advises that whenever you are working with subnets, you should always work within the range of /16 towards /28. It's safer. Okay, that is a very good range. Okay, it's not advisable to exceed to go below this /16. Okay, which means the number is going to be above 65,000, especially because of port numbers and the rest of them. And at the same time, /28, if you go below this, the numbers is going to reduce. The number of IPs is going to reduce. I think it's about 11 or so, because if you say /28, this is going to be 32 minus 28, which is 4. 2 raised to power 4 is going to give us, I think 2 raised to power 4 gives us 16. 16 minus 5 IP addresses, that's 5. That's 11 remaining. You see that? So it doesn't make sense to have 11 IP. It's too small. Okay, so imagine when you now increase this number, it's going to reduce. Okay, so your subnet should usually be within this range. So it can be /16, /17, /18, /19, /20, all through to /28. You understand? Now, once you are working with this range like this, that is good. Now, the next thing you need to understand is this: how did I break this down into these two things? Okay, I first of all made you to understand that if this subnet mark says that we don't change these two, we can only change these two. So all I did here to say was, I came here and said 10.0. I didn't change this one. I just came here and say 1.0 and say /24. Did you see that? So when I say 1.0/24, so this is within this network. /24 means that it is smaller than this one. Because if you do the calculation, you're going to notice that this /24 means that the number of IPs we'll get will be less than the number of IPs available here. I told you that it's not necessary that when you add them up, you will get this one. Okay, it's not necessary that when you add them up, you will get this one. No, the goal is just to have a subnet such that it still falls under this network range. Okay, so what I did was simply 10.0.1.0 and /24. Okay, and then I created another network so that it will not overlap with this, and it mustn't be 2. I can come here and put 20.0 and put /24. You understand? So if it's 4 subnets, I can say 1.0/24. I can say 2.0/24, 30.0.24, and 40.0.24. But of course, the 10.0 will still remain. All of them still falls under this number of networks. Does this make sense, please? Mr. Victor, let me know. Are you still confused?
Yes.
Okay, you get it now.
No, I'm getting it clear. I'm okay.
Okay, if you have any question, please, I want to encourage everybody to ask questions so that I can know how best to help us all. Okay, I don't want to assume and then we just don't cover a lot of things. Okay, all right. So I want to believe that everybody understands how I want to believe that everybody understands how IPs work now. So I said I was going to show you all some things. In fact, I actually wanted to this class to be put a hands-on class, right? So whereby every one of you will be implementing it on your computer systems, and then we can wrap up everything that has to do with setting up a 3-tier or 2-tier or even a 4-tier architecture. Okay. One of the things I wanted to discuss was the basic. Okay, let me see. Let's come here. Screenshots. There's some screenshots I got. I think this will help. Okay, this should help. Okay, now. All right, good. So my expectation is that everybody should be able to understand all this components. Okay, whether it's the subnet, the route table, the router, the elastic IP, the ENI, internet gateway, customer gateway. Okay, of course, the name has changed. The VPN connection, virtual private gateway, VPC pairing, VPC endpoints, and NAT gateway. There's so many others. Okay, there's so many of them that comes with it. Okay, but one of the things I want us to understand today is understanding these components. Okay, of course, if we also look at this simple architecture here, right, you see a simple VPC. We've all understood this kind of things, so I'm sure this is not difficult for anybody. Every one of us here, I presume, should be able to interpret this architecture and maybe implement something around this. Okay, but the most important thing for me is for you all to understand these components, and not just understanding the components. This is the most important one for me. I wanted you all to understand how this routing works. Okay, especially when you're working with a public route table and with a private route table. Do you understand? And understand how the flows of everything is going to be like. Okay. All right. So any questions so far before we just move to the next level and start implementing everything? And then I can start asking questions. Any questions so far from anybody? Are we good? Or let me ask this question. Do we all understand this? Have we all understood everything about this routing, the route table,
No,
everything,
no, sir.
internet gateway, NAT gateway, so that I can, I'm not sure if we're saying no, but
I don't understand it. Oh. I don't
okay.
understand it. Oh.
Okay. All right, that's fine. Okay, that's fine. So let's. I was thinking Chifola will defend me.
That's what you are.
Yeah, who's somebody saying something? Go ahead.
Jose. The picture I sent to you, what about it? I don't know if you still have it.
Okay, Mr. Ose, you said what?
I said that picture I sent to you. I mean that column, I didn't understand.
Yeah, I still remember your leading bits question and the rest of them. I go through that
Exactly.
Might not be able to. What will happen?
I'm no longer hearing you.
Okay.
I hope
Can you hear me now?
clearly. It's lagging.
You can hear me, right?
Yeah, it's okay now.
Okay, good. Thank you. So, I wanted to know how many persons are. Mr. Victor, I'm sure you should be back now. Please confirm and let me know. So, I wanted to confirm how many of you still have difficulty with the IP. Maybe you just need a refresher again to understand how this IPs work. Okay, just maybe just send me a DM. Okay, so what I want to do is just maybe put maybe 2 or 3 or 4 of you, right? Whichever, depending on the number. So you just get on a call, and then I can now start from scratch and put the whole pieces together. Okay, we just touch it very very well so that we learn it, and then I don't want to use in a reading way or just in a way that everybody's going to make sense out of it. Okay, so please just let me know if it happens to be just miss one person, then I'll just have to do the session for him. Okay, so please let me know after now so that I know I can schedule a day this week so that we can get on it. Okay, that's fine, Mr. Victor. All right, so there are 2 persons that are interested. Okay, so let's continue. Mr. Ose, don't worry, I'll still attend to your question. Okay, we'll just, yeah, I know, we'll schedule and then we'll get together and solve all these things. Okay, so you can come up with all the questions. All right. So once you see a typical VPC that looks like this, right? And then the VPC is gone further to break down into subnets. Okay, so this is what a VPC looks like, and this is the network address. Okay, and you see that the VPC is broken down into different subnets. And I'm sure you all know how this works, right? I've taught you how to do the calculation, and I also explain a simple demo right now. Okay, now I want you to understand that getting this is not a problem. The most important thing is understanding how the routing works. Okay, because if you watch here, I showed you that there are so many components here. Okay, if you watch here, there's so many components here. Okay, and when you implement a VPC and you start connecting all of them, these components are all there, and many more. Okay, so many other ones: transit gateway, VPC, VPC endpoints, and direct connect, and so many other components that are not even listed here. You understand? So you need to understand how they work. All right. So but the most important thing I want us to understand right now is just this routing, which is very, very important. Okay. So I decided to use this picture so that it's going to make more sense. Okay. So let's take an example that this is the network address we have. Okay. And this network address, we have 2 subnets. Okay. We have 2 subnets. Now, let me see if I have here. Okay, let me see. Okay, cool. All right. Okay, it's fine. Let's just use this one. So if you notice, this is a public subnet. If you notice, this is a private subnet. Okay. Now, what makes this public subnet? It's because this subnet has access to the internet. Okay, it has access. It will allow inbound and outbound traffic. But I think that's not a better way to explain it. Okay, I want you to understand that whenever you are working with on AWS, right, and you create a web public subnet, anytime you put an instance here or a web server, okay, and you want that web server to be able to download something from the internet, okay, so which means it's pulling it down from the internet down to your computer. That is inbound traffic. If you are uploading or sending something to someone, that is outbound traffic. Okay. Now, but I want you to understand that a VPC, every VPC has what we call a router. Okay. We have what we call the main router. Every VPC has what we call a main router. Okay. Now, this router, okay, it's what determines the route, okay, the direction in which traffic is going to go. All right. Now, on a VPC, if you want that VPC, remember it's a virtual network. Okay, communication can happen inside this VPC. Okay. Now, don't worry about whether this is public route table or private route table. It is what is inside this table that makes it public or private. All right. So in most cases, if you check okay, let's okay, I'll do the practical later. Okay, so if you check a VPC route table, the main route table, right, you will notice that all you will see there is something like this. You see 10.0.0.0/16. Okay, you see local. Okay, now that is what happens inside a typical VPC. Okay, a typical VPC. All right, now these two computers should be able to communicate. All right. So what I want you to understand, the most important thing I want you to understand here is this. If okay, let me see if I can do something here. Okay, let me use I'm hoping I will be able to. Okay, good. So if this subnet, okay, this instance here wants to communicate with this instance here, this is what happens, right? It doesn't just go to the route table, okay? Even though it is associated with the route table, it first of all, this is 10.0.3.48, okay? Now, it connects to the router. Do you understand? And the router will check the route table. Do you understand? So when the router checks the route table, it will see that 10.0.3.48 is within this network. Remember, this is /16. You understand? So this is the network. So the destination is local. So if this is local, this router will route the traffic to this guy. And then this computer here will be able to communicate with this one. Okay, so the router is what does the routing of the traffic. You understand? So the instance, whatever you put in the private subnet or in any subnet goes to the router. The router checks the route table, and from the route table, it drives the traffic to the right destination. Please, does this make sense? I want you all to understand that this is how it works, especially when you see this. Now, if you don't, once you see only local, that is a private connection. Everything is happening within this VPC. Okay. Now, let's take this other one, right? So the same thing with this subnet. Okay. If this subnet wants to this subnet here wants to communicate with this one, or this instance here wants to communicate with this instance, what is it going to do? It's going to get to the router. Okay. What will the router do? The router is going to check this route table. Okay. Now, because the name is public route table, that's the only reason why it's going to check it, because two of them are associated. Okay. Two of them are associated. But if there was only one route table, it will check the route table. Okay. So in this case, this router checks the route table. Okay. And it sees that this IP address here, 10.0.1.35, falls within this network. Remember, this is /16, which means this two is the network and this two is the host. You understand? So it falls within this network as the source. So the destination is local. So this router automatically knows that, okay, it's going to be inside this VPC. So this router will be able to now direct the traffic to this instance, and then communication will happen. You see that? Now, but if this instance says that, no, I actually want to go and download something from the internet, okay? Maybe I want to chat with somebody, okay? And there's an IP somewhere, maybe another IP, okay? Now, let's assume, okay, there's another IP, and this IP is maybe let's say 4 dot, for some reason, you bear with me because this, okay, I mean, it's not the best tool I can use to write this, but let's assume that this is 4.4.4, another IP address entirely. You understand? And the PC I want to connect to is here. Okay. This public subnet will not just go directly to this instance here. You see that? Now, what will this public subnet do? The public subnet is going to, okay, let's remove all this, the older thing. So remember, this is the PC wants to connect. So this public subnet is going to communicate with the router, okay, and say, I want to communicate with so IP, right? Or so PC, or I want to download something. So the router will say, okay, let me check your route table. It checks the route table and it says, okay, the IP if the IP wants to type, it wants to check, maybe it's 4.4.4, right? And it will check the first rule or first entry on this table. And this is not matching the network. Is it not true? So it means that this is not a local connection. Okay. In other words, it's going to be an external connection. So immediately you see 0.0.0, it means any IP from anywhere. You see that? So immediately this is the source, right? It means it wants to go external. So the destination is going to be what? IGW, which means Internet Gateway. Okay, so the router knows, okay, the destination is through the Internet Gateway. So the router will now take from the traffic coming from here, it will now direct it to the Internet Gateway. Then the Internet Gateway will be the one to connect to this guy. Please, do we understand it? This is how the communication happens. I'm explaining this to us because I expect every one of us to be able to demystify this when we are creating the table and doing the mapping. Any questions so far? Any question? Please let me know if you have any question. Are we good? Do we all understand? Are we good? Please let me know, friends, so we can save time.
Yeah, I understand.
Is the answer yes for everybody?
Yes, for me. I don't know for
Yes,
others.
yes for me.
Okay, great. Thank you so much. Thank you for confirming. So now we've been able to understand how the communication
Hello, sir.
works. Okay, go ahead.
Yes, I want to ask something like, is it the same scenario the way you explain now? Is almost like the way you explain for how to connect in, is it CloudFront or cloud, no, it is in CloudFront or no CDN? Like if MTN, in our foundational class, is it the same way it happens? Like, okay, let's say we are trying to connect to a particular thing. So the way it goes from MTN to different server, is it the same way route table also works in this place? Because I remember very well.
If I understand, you're not far from I think you're correct, right? Even though I didn't understand the question correctly, but ideally, if you want to every communication you do, right, is actually what we call a route table, especially if it involves a router. There's always something called a route table. If there is a switch, there's also something a CAM table. I'm correct. I'm sure it's called CAM table. You understand? So there's always a table where all those information, the routes, all the entire routes, the entries will be logged there. You understand? That is how the router knows who is who. Because this computer, 10.0.1.35, doesn't know this computer. You understand? And it doesn't know how to reach this guy, or how much more how to reach another computer outside the internet. Okay? So the only way it can do that is to talk to the router. Okay? And the router will be the one the router knows the entire routes. And how does the router knows the routes? With the help of the route table. You understand? So the route table that comes together with it. You understand? So it's that route table that the router use to look up the information, the entries for those routes. Okay? Because these routes, some of them you will be the one to enter them yourself. Some of them will be entered for you manually when you create those components. All right. So some will be doing these things hands-on. All right. So once you're able to access it, then you're good to go. Okay. So the most important thing is whether you are using the CloudFront or you're using what is it called? Yeah, CloudFront, right? So there'll always be an internal router to route the traffic from one point to another. Okay. So now we've been able to understand this. Most important thing, do not. Okay, somebody's asking a question. Okay, go ahead, please.
What if like a computer is wanting? What if a
Mr.
computer
Ose,
wants to like?
I can hear you audibly. Would you want to raise your voice, please?
Can you hear me? Can you hear me now?
Yes, please. Go ahead.
What if the system outside is wants to connect into that that VPC? I mean incoming traffic, incoming connection. Yeah, I mean like incoming connection. The one you explained now is
Yeah,
different, right? The one you
outgoing.
explained now is outgoing, right?
Okay.
What of incoming? Or how does it
Okay.
work?
So if it's an incoming traffic, right? And so it
Yeah.
depends on what's happening, right? So this internet gateway is designed to receive traffic in and take traffic, inbound traffic and outbound traffic, right? So if this computer was trying to communicate with a computer inside this network, so this computer will go through the internet gateway. And the internet gateway does not do anything. The only thing it does is to talk to the router. You understand? And the best the router can do is to check the route table. You understand? Where this internet gateway has its entry. So definitely it's going to be the public route. You understand? And if the network
Yeah.
exists, the network exists within this route, definitely it would just go to that particular device, to that particular resource or machine in that network, and then send the traffic or send the data, as the case will be.
Yeah.
Does that
Okay,
make
it's just
sense?
like the same thing. Yeah.
It's just the
Okay.
same thing, but of
Yeah.
course they follow the same route table,
Different.
the same order.
Yeah.
The
Yeah.
endpoint, the most important thing I want you to get from everything is that there is a router. This subnet does not communicate with the route table just like that. No, this private subnet does not just communicate with the private route table. It communicates with the router, and then the router checks the route table, and the same router will now be the one to send the information. Do you understand? So it's not even the route table that
Oh,
now sends it. No. So it is from the router. The router checks the route table. It's like a brain, a memory. It checks its database, right? It checks the route table and it finds where the route is. Then the router decides where the traffic or the path will be. So another word for routes can be paths. You understand? Just like in the case of internet gateway. So if this guy wants to download something, so it goes to the router checks its route table, and he knows to go to any other network. I have to go through the internet gateway. The router will now send it to the internet gateway, and from the internet gateway, it will go to any other computer outside the network. Okay,
okay.
so
But
we've done great job.
I want to ask,
Okay,
does that mean that I can access a private subnet outside the VPC
no,
if I have the IP for the private IP?
no, it's not going to allow you because by default, so the way it works is this. Even if you have the IP, it will not work. Now, there's a way this private subnet, once you want to make something a private subnet, right? It simply means that it's not going to allow inbound traffic. Do you
Okay.
understand? It's not going to allow inbound traffic. Okay, so it cannot allow inbound traffic. You can also configure it to take out, but there's a way we're going to show you how to configure it, but it's not going to allow inbound traffic. Okay, but of course we can use things like NACL or NACL, or we can use security group to determine how you can reach it. Okay, but again, for the most part, no. Even if you have the IP address, you will not be able to communicate with it if it's in a private subnet. Okay.
Okay, sir. Thank you.
All right, that's fine. Okay, so let's move on. I'll click on reset and okay. Let's right, so this. So the next thing I want to show you guys is this NAT gateway, right? Then I'll explain some few things. Please, I want to encourage us to please mute ourselves. All right. If for any reason you're muted yourself, please let's mute. Okay. Anybody, please. All right, good. So if you watch here, right, you will see that this is the same network thing we did, right? Now, but if you watch closely, right, so this is our private subnet, right? Now, if on this private subnet, you decide that you want to have your database here, okay? So let's do it again in a way that everybody is going to understand what's going on. So let's say that in this private subnet, you want to have your database here, okay? You want to have your database. So let's say this is DB, okay? And here you want to have your web server. Sorry if my writing is not so friendly. Okay, so this is the web server. This is the thank you. So this is the web server. This is the database server. Okay, and you know that database server or database or any resources any resources you don't want to access the internet. You don't want people to have access to it, right? That's what you put in a private subnet. Okay. Remember, I told you all subnets are the same. Okay. So what differentiates a public subnet from a private subnet is what you put the configuration rules you add to the route table. So it's the route table that determines whether it's going to be a private route table or a public route table. So once you now define the public route table and private route table, then you now associate them. In other words, you now connect both of them together. All right. So let's assume that this database, right? In most cases, you want to update this database. Okay. You want to patch it, or you want to just maybe update the MySQL server. Okay. Or you want to update it. Let's keep it that simple. Okay, or the operating system of this database server. Okay, so, and you know that for this to happen, it's supposed to go through the internet. Is it not true? To be able to get access to whatever it wants to do. But that's not the route we are going to take, right? So what this private DB server is going to do, it's going to go through the router, okay, and say, I want to be able to connect to the internet. I want to do something, okay? So the router will say, okay, let me check. The router is going to check the route table, okay? Now, of course, where you are trying to go to might be www.mysql.com, right? So there's what we call DNS host options, okay? Or there are a lot of things. Of course, you all know the concept of DNS, right? So those DNS URL will be invariably converted to an IP, right? So, and all these things happens with the speed of light. You understand? So it will convert. You are typing www.google.com or www.mysql.com, right? And eventually it will be converted to an once DNS has been done, it will be converted to an IP, right? So the router is going to check that IP through on this route table to know if that route IP falls under this network. Okay, if it falls under this network, it means it's a local connection. The destination means local inside this VPC. Okay, but if it doesn't fall under this network, it means it's going to go anywhere to anybody. Okay, and if you see in this case, the destination is what? NAT gateway, network address translation gateway. You understand? And take note that this NAT gateway, we put it in the private route table. So the router will be like, oh, I should go to the NAT gateway. So where is the NAT gateway? The NAT gateway is usually placed inside the public subnet. Take note of this. It's very important because people get confused. Okay, the NAT gateway is placed inside the public subnet. Okay, so this router will go after confirming it will now connect to the NAT gateway. So it goes from here to here to here. Then the router sends it to the NAT gateway. So the NAT gateway, right, will now send the traffic to the router again by looking through this what is it called, route table. The NAT gateway, okay, because it's supposed to send that connection outside. So the NAT gateway will tell you, check, for me to go out, I need to go through this address because this is local connection. Okay, because remember the IP was pointing to the NAT gateway, right? And then the NAT gateway will say this is a local connection. So this is invariably where I'm going to. So the NAT gateway will go to the router and the router will check the route table and it sees that it's supposed to go through the internet gateway. The router will now send it through the internet gateway. Do you see that? So this is exactly how it happens. Okay, I know it looks like it looks a little bit confusing, but this is exactly what happens, and it happens very, very fast. Okay, so the private instance, okay, communicates with the router, okay, and the router checks here and it sees the NAT gateway, and locates the NAT gateway, which is available where in the public subnet. Okay, and so the NAT gateway will will of course communicate with the router and let the router know that for me to be able to, I need to go through the internet gateway. The router will check the route table and find the IP that leads to the internet gateway, which is this. So the router will be the one to direct it to the internet gateway. And from here, it will be able to go to the internet to download it. And the NAT gateway is intelligent enough to know that through the port or that route that it's opened to go through the internet gateway is still the same route. You know, when it's downloading something from the internet and it's coming back, so it's like inbound traffic. What is going on is an outbound traffic. Is it not true? You're going to download something. So when it's coming back, it follows the same route, okay? And go through the NAT gateway, you understand? And eventually it comes back to this, okay? So this is not to say that another person can communicate with a private router, with a private instance. I don't know if you understand. So the NAT gateway is a one-way kind of traffic. Do you understand? The NAT gateway is a one-way kind of traffic. Okay, so it only allows you to go out of the internet gateway, out of this VPC. Okay, so if you want to do anything, you have to go through the NAT gateway. You understand? You want to download anything, you want to do anything from your private subnet, it has to be through the NAT gateway. Do you understand? So nobody else can go through this private subnet, okay? Except the same traffic that went through this NAT gateway is only that same traffic that will come back through the NAT gateway because it knows the particular route and knows the configuration. It's just like an encapsulated packet data. So it knows the source and it knows the destination. So when it's coming back, it knows what to do. Please, does this make sense? Does everybody understand the NAT gateway now? So
Yes, sir.
if we
I have a question, sir.
all right, go ahead.
So please,
Is it
I think I'll need
possible?
to take it.
Okay. Hello?
Okay,
I
I
think
don't know
someone-
who, okay,
You can go on. You can go on.
I
I'll
don't
ask
know who
mine.
it is. Okay, someone saying something, please. Would you say that again, please?
I wanted to ask something.
Okay, go ahead.
Is it possible, even though the NAT gateway is only when it's trying to communicate to external, maybe to the internet gateway or to the external, how do I say it? Like trying to connect outside the local area. Is it possible to also get that same path to connect from outside source to the NAT gateway and have access to the private subnet from outside the VPC? Is it possible as an external?
You are saying, is it possible for another external resource to access the private subnet through the NAT gateway?
Yes, sir.
That one? No, it's not possible. It's not.
Okay,
It's not.
sir.
It's
Because
just a
I'm trying
one-way
to-
thing.
I'm-
So
I'm just trying to decode it because
you're looking
since
for flaws. Looking for, yeah, I get you. If it was possible, you would have.
all right,
It
all right.
defeats the purpose. It's just like it's a one-way thing. Okay, it only allows outbound traffic. It does not allow inbound traffic.
Inbound
You understand?
traffic. All right.
It does not allow
All right, sir.
inbound. It only allows outbound traffic. And if you want to counter that statement, why I say it doesn't allow inbound traffic but allows outbound. So, but in this case, if you are going to download something from the internet, is it not going to come back? The answer is yes, because the NAT gateway is smart enough to know that it's just like you sent somebody on an errand, right? You know who you sent on an errand. So it's possible the person has a stamp ID and reg number. So that the gateman opened the gate and allowed somebody to go out. Nobody is allowed to come in. So once that particular person that we sent out comes back, we know the person. Is it not true? We identify the person with his ID, reg number, and the rest. Then we let that same person in. So that's what the NAT gateway is doing.
Okay.
Do you
Thank you,
understand?
sir. Yeah.
So that's it. All right. I think another person was asking a question. Please, would you want to say that, or do we continue? I don't know.
I was asking the question,
Oh,
sir.
Precious.
But
Awesome.
yes, good evening, sir. But
How are
I
you? Good
think I
evening.
understand from I'm fine. I think I understand from the explanation you just did.
Okay,
I
awesome.
understand.
Okay, great. All right. So far we've been able to talk about the NAT gateway. Okay, we've talked about let's. I want us to do a lot of hands-on. So let me see if I. Okay, I don't want to talk about VPC endpoints now, but if there's one thing I know I have explained is that I told you all that S3 is not inside a VPC. If you all remember, I talked about that before. Okay, so VPC is inside a region, but S3 is not inside a VPC. Okay, so let's so if you want to send something from a resource to store it on S3, right? We one way we usually do it, okay, is to we can use something we call a VPC endpoint to connect that resource to the S3 in a private link, like in a secure way. But again, we'll touch all those things later. Okay, so let me see. I said I was going to explain something. Once I explain it, then we will
Sorry.
get hands-on.
Good evening. Just a quick one.
Okay, go ahead,
Yeah,
please.
good evening. Yeah, is S3 the only is S3 the only endpoint for a VPC? Like, is it only S3 that can be used?
No, we also have DynamoDB. Okay, so the thing there is this, right? Maybe I didn't word that properly, right? We have resources. Okay, anytime you are learning AWS, right, and you mention a service, every service has its what we call scope. If you remember, we did this during our 8 weeks of the boot camp, right? Where we talked about every service having its level of scope. Okay, like IAM. IAM is globally scoped. You're not, in other words, you don't need to be in any region. Okay, IAM is available in every region. You understand? So IAM is not region scoped. Okay, it's global scope. Do you understand? So there are some services that are region scoped. They need to be in a particular region. Okay, just like S3, for instance. Okay, you can have S3 in one region, you can have another S3 in another region. Do you understand? It's region scoped. Okay, now VPC in this case, it's not necessarily region scoped, but I want to use the word availability zone. Now, why it's not why it's different from what is it called? The S3 is because S3 can be in multiple regions, okay? But a VPC is one particular region, okay? You can have a VPC in one region and have another VPC in another region. You understand? Of course, you can have S3 in another region as well, okay? But just know that S3 is not in the same scope, okay? I want you to see S3 more like a global scope, just like IAM, just the same way with DynamoDB. As I think we also have, what is it called? Even I think Route 53 falls under that region. You understand? Under those scope. Okay. So whenever you think about a service, just think about the scope. You understand where it falls under. So when you are designing the architecture for it, maybe this is a VPC architecture, right? If you watch here, this is our AWS, okay? And then this is the region. Once we choose the region, okay, maybe we say is US East 1 region, okay? You agree with me that inside every region, right, there are different availability zone, okay? US East 1A, US East 1B, US East 1C, okay? So is that VPC? So you don't create the VPC. The VPC is going to span across all the availability zone, but it's still inside that region. Okay? Did you see that? So they are not, so this VPC can stay on its own. The S3 can stay on its own. So the S3 is not inside the VPC. Okay? So whenever you see some architectures and they put the S3 inside the VPC, maybe for lack of space, okay, they're just putting everything there. But ideally, S3 is not supposed to be inside a VPC. All right. So the re-architecture keeps S3 outside of a VPC. And if you want to connect any resource to the VPC or any other resource that is not in the same scope with the VPC, you need to find a secure way to connect it. Do you understand? So things like VPC endpoints and the rest of them. So we'll touch about all those things at a later time so you can understand it better in a more practical way. I hope that helps. I think, I don't know if it's Mr. Ose that asked the question. All right. So,
Yes, it does. Thank you.
Okay, thank you. You're welcome. So let's continue. So we all know, everybody here knows what a subnet is, right? I've been able to tell you that a subnet is so regardless, it's just a subset of a network. You understand? So now whether it's public or private, it doesn't matter. You'll be the one to configure it based on the rules. We all know what a route table is. And I told you the route table works together with the router. Is it not true? The router will always check the route table before it can implement the direction or the route in which the traffic is going to go within the subnet or outside the subnet. Okay, now this is the most important one you should understand, elastic IP. Now, I want to believe that from our previous classes, every one of you know that when we talk about IPs, we are either talking about public IP or private IP. Is that true? So, when we say public IP, private IP, we also establish the fact that IPs can be statically assigned or dynamically assigned. Do you understand? Okay, so I want you to understand that elastic IP is the kind of IP, or rather, let me use the word, is a statically assigned public IP. Okay, it's a public IP, but it's what you can assign to your EC2 instance. Okay, I want to believe that everybody here has created an EC2 instance before. Is that true? If you've all created an EC2 instance, you will agree with me that if you stop the EC2 instance and start it back at a later time, you notice that the public IP is going to change. Is that true? It's good. If you've okay, just to be sure, are we all? Is that true? Is that
Yes,
same
sir.
with everybody?
Yes, sir.
Okay, good. So
Yes, sir.
now, if the public IP changes, it means that that IP was dynamically assigned. Dynamically assigned. AWS is the one that assigns that IP dynamically. So for every time you stop the instance and start it again, it dynamically assigns a public IP. If you stop that same one and start it again, it will dynamically assign another IP to it. Do you understand? But if you say, no, this is very tiring, especially if you are working with a team. As a cloud engineer, you're working with a team, right? And then your developers are complaining that you should give them an IP that is static, that doesn't change, so that they can be able to work on their database without having downtime whenever the instance go down. Okay. Now, even though it's expensive, what you need to spin up is called an elastic IP. Okay. So you need to go to AWS and be able to create an elastic IP. Okay. Once you create an elastic IP, then you associate it. Okay. I would have said assign it, but the keyword AWS uses associate. Okay. So you associate that IP with the resource. Okay. So you can either associate it to an instance or associate it to the network. But again, I don't want to confuse you. Just know that the elastic IP is what we call a statically public IP. A static public IP. That's what an elastic IP is. Okay. So once you attach it to the instance, okay, even if you shut down the instance 20 times, it will still have the same IP. The IP does not change. I want to believe everybody knows how to do this. So please, you can practice it just to be sure. Okay. Create an EC2 instance, then go to the search bar, type elastic IP. Okay. Or do you want us to do it here so that everybody understands it? Let me know if you think if we can do it so I can move on. What do you all think? Please let me know just to be sure.
Yes, sir.
I don't think I heard you guys. What do you think,
can do
Fred?
it, sir.
I said I can do it. Okay, that's fine. Let's okay, let's see. AWS. Okay. Code
I think
cloud.
using your right.
So I think you should finish explaining it, then you show us one by one on the dashboard.
I think okay. I think that would be a good one.
So
Yeah.
you just finish and
Okay.
now once.
So let's talk about this ENI. That's a good one. Thank you. So now
I think we should, it will be better like explain everything, then do probably
immediately.
a project implementing everything we've
Yeah, we're
learned
going to do a
on
project.
VPC so
We're going to
far.
do a project to put them
Okay.
together. We're definitely going to do a
Okay.
project to put them together. Okay. But I want you all to understand it. If I just go ahead with the project, it will be very confusing. Okay. So I want you to be able to understand it first of all, so that when we put them together, it will make a lot of sense for you. Do you understand? Right. So so what is this ENI? Elastic Network Interface. Friends, do you still remember when I was teaching you guys networking? Let me show you something. So let's assume a physical computer. So there's something called NIC, Network Interface Card. Okay, NIC card. Okay, so the NIC card is actually the interface or the adapter, right? That enables your computer to have an identity, an IP address. Okay, without the NIC card, your computer might not have an IP address, except you are using maybe a wireless card, right? So let me show you what it looks like. So this is the Wi-Fi, but this is the kind of card I'm talking about. So if you see some PCs, all right, some PC, okay, let me say if I can show you. If we have any physical computer. So the most important thing is once you connect this NIC card to this, okay, with that you'll be able to get an Ethernet, and with that it will give you an IP address. But this is what it looks like anyway. And I've explained this before that we have wired NIC and we have wireless NIC cards. Okay, so but this is what it looks like typically. Let me see. Good. So if on your computer systems, if you plug it to the motherboard, there's a way we slot it. You see these chips here? There's a way we slot it to the motherboard. Let me see. I used to do hardware. So using that terminology, let me say slot NIC card to motherboard. Okay. So click on this. So this is what it looks like. So this is another type of card, but this one is not a NIC card. This looks like an expansion slot or a video card. So, but this is what a motherboard looks like. Okay. So on this motherboard, you slot this area here. So where we slot it, just the way this person is pinning it down, you see something that looks like this. Okay. So once you pin it down, this outward area is going to come out of the PC. Let me see if I'm going to find a good image that depicts this. So watch here. Can you see? This is the board. So once you put it in the PCI slot, so this is a PCI slot. Okay. So once you put this network card on one of these slots, okay, and this is a typical Pentium 4 or Pentium, whichever type of computer, something like this, it's going to come out behind it. You understand? Let me show you so you see how it looks like. Let me see. Okay. Let me see. Let's see. I'm not saying something that looks. Well, I'm so glad at least you all understand what I'm about. The most important thing is that you have an idea of what I'm talking about. Once you just slot it here, it's going to come behind this. I know if I show you one of these videos, you will see how it looks like. It will come out through these openings, and then you will see this slot, and you'll be able to put your cable behind it, your RJ45 cable, and then you connect it to a router. You understand? That's how we usually do it. So this is what a typical motherboard looks like. Do you understand? Okay, good. So now you've understood what an NIC card looks like, right? So, and I've told you that this NIC card is what helps you to uniquely identify your computer. Okay, so this NIC card bond in it, we can be able to get our network card. We can also be able to get our MAC address. Okay, now, but I want you to understand that once your computer has an internet, okay, with the help of that Ethernet, that NIC card, okay, on AWS, right, what we call it is this Elastic Network Interface, ENI, okay? If you look at this image, you know, it looks similar with what we have there, okay? So anytime you create an EC2 instance, okay, friends, I want you to know that that EC2 instance, this ENI is usually attached to the EC2 instance. Even though you don't see it, sometimes it's attached to it by default. If you check your AWS account and search for ENI, it's possible that you will have one of them there. Anytime you create an EC2 instance, you will notice that there's one there. Okay. Now, but this question usually come out during exams, and also it comes out during interviews. Okay. So what happens if your physical computer is down? Okay, maybe you have an EC2 instance here, right? And if okay, let's do our sketch again. So you have your EC2 instance here, okay? And this EC2 instance seems to be down, or we're having difficulty starting up this EC2 instance, okay? Now, the way it is, when you spin up this EC2 instance, this EC2 instance has what we call the ENI attached to it. You understand? Let's put this and say this is the ENI. And this ENI here, okay? This ENI here, this elastic IP, okay, is attached. So there are different ways. This elastic IP can be attached to the ENI or can be attached to the EC2 instance. Two ways. It can be directly attached to the instance or can be attached to the ENI. Okay, so what we usually do is this: anytime an instance is giving you issue, okay, to solve this problem is this: you can create another EC2 instance, you understand, then remove this ENI and attach it to this EC2 instance. And because this ENI is attached, this elastic IP is attached to this ENI, remember this is an IP that comes with the network card. So because this IP is attached to this network card, once you remove it and place it to this, you will notice that your customers, if this IP here is 4.4.4, they will not know that even if this system is down, you understand? Even if this system is down, because it's just the network card we are changing to another new instance, the EIP does not change, which means the IP will still be 4.4.4, even if we change it to a different instance. Please, you understand my analogy? So whenever you have a downtime like that, okay, maybe the computer is down and you know that this is going to automatically impact your work, instead of you creating another EC2 instance, right? You can create another ENI, or you can attach the elastic IP directly to the instance or to the ENI. I hope this makes sense to us. So that's the relationship between this elastic IP and elastic network interface. Okay, so this is just a card that helps us to work with an elastic IP. Okay, whenever you see the word elastic in this context, is virtual. Okay, it's virtual, but it's just AWS favorite way of giving things name. Okay, all right, because you won't say this IP grows and reduces. Okay, go ahead, please.
Does that mean if we are creating another EC2 instance, it won't come with ENI, and we have to configure another ENI to it? And how do we now move the elastic IP to the new EC2? Is it that we are still going to use the same old EC2 that is down? It will automatically connect to the new one, or how does it work, sir?
You can be the one to attach it manually. Just like in this case, once you create the EC2 instance, if you already have it there, the EIP, you can now choose to attach it to a different one. Don't worry, I'll show you. I'll show it to you so you can see it at a later time. Okay?
Oh, okay, sir.
All right. So we've talked about internet gateway. All right. So in every VPC, in every VPC. Internet gateway is that component that
I'm
we
sorry,
have on the
but
VPC. Okay, go ahead, please.
I'm sorry, but I didn't get the concept you just explained about the elastic network interface and all that. Really sorry
Okay,
for taking you.
that's fine. Okay, so importantly, right? We are trying to establish the fact that okay, let's take this away. Okay. So first of all, the most important thing we want to establish here is this, right? That on a physical computer, okay, if let's put on a PC. Let's this. Okay, let's see. Let me see if I can find a computer that already has it attached. Let me see. It's not. Okay, let me see. Okay, so ideally, this is a physical, this is what a computer looks like, right? You know, computers comes in different sizes. In the technical term we use is form factor. Form factor. Okay. Computer comes in different forms or form factors, right? So we have towers, we have desktop, okay, we have laptops. They are all computers, but they have different form factors. Okay. So this is a tower or what some people call desktop. All right. So, but if you go to some markets to buy a computer, if you go to some schools, universities, you see this kind of computer. It looks, that's the shape for, if I type Pentium 3 computer, right? If you come here and go to images, this is what you're going to see. I'm sure you've seen this kind of computers everywhere. So if you've seen this kind of computer systems, okay, this is what it looks like, right? And you see the inside, this is what it looks like. Okay. Now, while I'm not talking about hardware for now, so I just want you to know that this computer system, right, has a lot of boards here. Okay. Now, what makes this computer to be able to communicate with another computer? This computer has an IP address. Okay. So the IP address is what enables you to communicate with another computer, just like you have a phone number. If you have a phone number, another person has a phone number. Everybody's phone number is unique. Do you understand? Everybody's phone number is unique. I want you to understand that now. So every computer has an IP address. Okay. Now, I want you to understand that if every computer has an IP address, it's also important to know that how do they get this IP address? They can get this IP address with the help of what we call network interface cards, NIC card. All right. So this NIC card, which is what I show you what it looks like. Okay, this is what an NIC card looks like. This is the physical structure of what an NIC card looks like. Okay, now if you look at this, you see this is how it looks like in a laptop. You see that? It may not necessarily look this big like in some desktop. This is how it looks like in a laptop. Okay, in most laptop it's usually wireless. Okay, so that's why if you see types of NIC, we have wired, we have wireless. Okay, so if you watch here, you see this is wireless LAN. Okay, this is what a wireless network interface card looks like. So that's why you need to be careful when people pull out when you go give people to go and fix your laptop. You understand? And you give it to them, they just lose it and touch one or two things. They can just steal this network, this wireless card, and you won't know because probably you don't use the laptop, right? Or maybe you just told them to check it up for you. It's when you go later and you realize that it's not connected to the internet, even if it's turning on. You understand? So sometimes people don't know the value of all these things, but again, that's not the essence of your question, right? So once you understand that there's such a thing called the network interface card, with the help of this network interface card, our computer can be recognized on the internet. Okay, this network interface card will grant our computer an IP address. Okay, so if we are supposed to do this practically, okay, we're supposed to do this practically, you will understand that if you check here, this is my computer system, right? Now, if I come here and type control panel on my PC, Windows PC control panel, I click on this. If you're using Windows, please, this is how it is. If you're using Mac, I'm so sorry, please. But Windows, if you come here and type network and internet and you click here, right? Just click on what is it called? Let's see, view network and computer devices. No, sorry. Jeez. Click on change adapter settings. Okay, good. So that's what I wanted to click the other time. Okay, change adapter settings. Of course, there are so many ways to do this thing. You can always come down here and look at your network. When you see this network here, right? Right click this, your network here. You can always see network and internet settings. And from there, you can click on change adapter settings. These are two ways to get to this location. And if you come here, you can see the adapters we have. So my computer has a Wi-Fi, a wireless network interface card. Can you see when I hover my cursor on it, it tells me the type of the adapter. It is the network interface adapter that my computer is using. Do you understand? So, and some people have physical, the network interface card on their own computer. You see Ethernet written on it, Ethernet written on it, okay? But these are other types of interface cards that comes with, depending on the software you installed on your computer. Now, let's focus. So if this is the wireless interface card I have on my computer, if I want to be able to assign an IP to this, my computer, I will right click on this and select properties. All right. Now, when I select properties, what we usually do is to scroll down. You're going to see IP protocol version 4, Internet Protocol version 4. You select this and select properties. You see that? Now, when you select properties, you're going to see this. Okay. Now, from here, you see that we can click on use the following IP address, and then you can assign the IP address and the subnet mask, and you click OK. You see that? Now, or you can click on obtain. So, but we usually use this obtain IP address automatically, and it picks it up from our router, because with the router I'm using, there's a DHCP configured on it. Okay, so this happens automatically. So the DHCP provides the IP address, and that's what I'm using to connect on my computer right now, access the internet. Do you understand? So even though you cannot see anything here, but it was here before, because this computer is using the IP, it's getting the IP using DHCP. Okay, so this is how the IP address is being gotten. Okay, so now you've understood how it works locally, okay, on your physical computer. We are saying that on AWS EC2, on AWS, right? Remember that you are using AWS infrastructure. AWS is another person's computer or another person's network, right? And they want to share these things with you. Okay, so of course, if you want to pay for your own, you can pay for it. That's what we call it. We have tenants. That's what we call tenancy. Okay, so you can have the default or you can have dedicated. When you choose dedicated tenancy, it means you want AWS to give you a dedicated resource. If it's a router, AWS is going to give you a dedicated router that is not being shared with anybody. You understand? Because all the VPC and everything you are seeing, those routers and the rest of them, most of the routers, you share it with other people. You understand? But some companies can say all their VPC setup, everything, they always choose dedicated for the tenancy. Why? Because they don't want it to be shared with anybody to avoid any form of attack. You understand? Because they have the money and security matters a lot to them. Again, let's not deviate. So now you've understood the network interface card, right? AWS calls it Elastic Network Interface. What I called NIC here, a few minutes ago, this network interface card is what AWS is calling Elastic Network Interface, ENI. Okay, so whenever you spin up an EC2, okay, whenever you spin up an EC2, I am telling you that automatically there is an ENI attached to it. Okay, there's an ENI attached to it. Okay, let me see. There's an ENI attached to it. So this ENI, you can now attach So it comes with an IP address. You understand? It comes with an IP address. That's the one whenever you automatically assign a public IP, that is what the IP comes from, this ENI. Do you understand? It's been attached to that ENI. Okay. Now, I want you to know that now this is not a question somebody asked, but do you know that an EC2 instance can have 2 IPs? One device can have more than 1 IPs. And you see, this is made possible with the help of these ENIs. You understand? So you can create another ENI and attach it to this EC2 instance. Or you can attach the elastic IP to the instance. So you can have more than 1 IP attached to an instance. Again, that's an aside. So what I want you to just understand is, for any reason, this network interface, this ENI that has an IP, if this instance EC2 instance is having a problem, right? You can create another instance, okay, and attach this same ENI here to this one. Do you understand? And it will have the same IP that was attached to this one, is the same IP that it will be using here. So the customer will not know that you have changed the instance. The customer will be seeing the same IP. So if this instance was 4.4.4, the public IP. So even if this instance is down and you remove the same ENI and attach it to a new instance, the customer will still be seeing 4.4.4 as the public IP. Why? Because of the help of this ENI. Please, does this make sense? So
Hello,
you
sir.
can also attach the
Yes, sir,
elastic
it does.
IP to the ENI or
I
directly
have a question, sir.
to the IP.
Sir,
Okay,
in
go
a
ahead, please.
in a real life situation, do you have to do
Mhm.
this manually, or it is automatically, will it be resetting automatically, or you have to reattach the ENI by yourself manually?
Okay, yeah, you have to do this manually. But for the ENI, you don't have to attach it automatically. This happens. That's why whenever you create an EC2 instance, you notice you didn't have to. In fact, some of you are hearing the word ENI for the very first time, right? You don't know that this happens behind the scene. It's actually there. Do you understand? If you just go and search have you ever tried to delete a VPC and it tells you something is required for something? Maybe if you try deleting something, you realize what I'm saying. Okay.
Yes, sir.
All right. So I hope I've answered your questions. I hope that helps, Mrs. Precious. Let me know if that makes sense. Okay.
Yes, sir, it makes sense.
All right, great. All right, friends. So we all know what an internet gateway is right now. So the internet gateway is going to be on top of the VPC. Okay. It's what allows inbound and outbound traffic into the VPC and out of the VPC. You understand?
Security man.
You say?
I mean, is the security man.
Not necessarily. No, in fact, to be honest with you, this guy is just there. It's just like a gate. Okay, yeah, I understand what you mean by security man now. It's just like the gate man. He just stays there and his job is to open the gates if someone is coming in. And if somebody's going out, it doesn't even ask question. That's the thing, right? It doesn't ask questions to say, okay, who are you, or you're not allowed or anything. No. His job is just to let you in and let you out if you're coming in or going out. All right. So there's something we call customer gateway. Okay, so the name has changed. Okay, but don't worry, when we get there, we'll talk about some of this thing. But this kind of gateway you see here, it's what we use to attach the when you a company can have their private data center. You understand? A company can have their private data center. Okay, now if you want to connect your private data center to your AWS VPC, right? If you want to connect your private data center, the network you have on your private data center to your AWS VPC, we use this customer gateway to connect them. Does that make sense? Please, do you understand? So these three actually work together. So these three usually works together. Okay. So if you've ever heard about VPN connection and the rest of them, okay. So if you want to be able to set up a private network, okay, from your private data, just like a bank, for instance, okay, they have their own private data center. All right. So that private data center, in most cases, they connect it to their if they have a VPC on the cloud, they can connect it such that the computers in their private network can talk to the computers on AWS VPC, and it will be communicating without any breach. It will look as though they are all in the same network. You understand? So this is made possible with the help of this kind of setup. Okay, we might do a project that touches these things so that you all can understand it better. Okay, so then we have VPC pairing. Okay, so if you have two or more VPC, one VPC in one region, another VPC in another region. If you want to join those VPC together, we use VPC pairing to do that. Okay, that's what VPC pairing is used for. Then I've told you about VPC endpoints. It's just a private, secure way we connect other resources to our resources on a VPC. Do you understand? And these resources I'm talking about are resources inside AWS, unlike these ones, okay, that are connecting you outside AWS in your private data center. But this one is connecting with resources inside AWS. You understand? Just like S3 or DynamoDB or any other resources. Okay, you want to connect that resource to a resource inside your VPC. That's what this helps you to do. Do you understand? I'm sure you all know what a NAT gateway is now. Any question from anybody? Any question from anybody? All right, so let's continue. If there's no question,
I have a question.
All right, go ahead.
My question goes like this: what's the difference between NAT gateway and NACL?
NACL simply means NACL, Network Access Control List.
Yeah.
So it's like security group. Okay. So but maybe when I start talking about what is it called, security group, you understand better. But I want you to know that in simple terms, right? You know, whenever you do something on the security group, right, it affects the instance immediately. Is it not true? It determines the connection that can go in and out of the instance, right? But NACL, on the other hand, is not at the instance level. It's at what we call the subnet level. Do you understand what I mean? Subnet level. For instance, this is a subnet, right? So if you use NACL, every resources inside this subnet will be affected. So if you put a rule here that says no traffic, outgoing or incoming connection, you understand? You put a traffic and say that no, this connection cannot come in, or only this port is open. It's going to affect all the instances inside this subnet. You understand? But security group is only applied on a instance level. Each of the instances there. Do you understand? It applies it on an instance level. That's one of the major difference between security group and NACL. Do you understand? So NACL is totally different from NAT gateway. Do you understand? So NACL has to do with the rule or the mechanism, the it's like a firewall. It's another type of firewall that we use in determining how we access our subnet. I think there's something like that here. Let me see. I think, yeah, good. So this is it, right? So security group operates at the instance level. Network ACL operates at the subnet level. It supports allow rules only. Okay, just like security group, it's only say I allow this port. I allow ports. I allow traffic TCP port 80 to come through my instance, or I allow 3305, or I allow so number of ports or traffic TCP and the rest to go through my instance. So it's allow rules only, but the NSA supports allow rules and deny rule. So on the subnet level, you can deny and say anybody with so IP, I've denied it from entering this subnet, but you cannot do such a thing on security group.
Okay.
You understand what I'm saying? Good. So, and security group is stateful. In other words, it remembers whatever you configure. Return traffic is automatically allowed, regardless of any rule. What do I mean by return traffic? If you allowed a rule to go out, that traffic will automatically come in. I don't know if you understand. It's just the same thing I said through the NAT gateway, whereby you want to download something. Okay. If it's going out through a particular port 80, that same thing that's going out, it will automatically be allowed to come back. It's stateful.
But
Do you understand? But NACL is stateless. Return traffic must be explicitly allowed. In other words, if I don't define it that that traffic must, that so port number or so IP is allowed to come back in, even if I communicated with it. So I can send you a message, okay? But if I do not explicitly state that that IP can communicate with me, even if I sent a message to you, you cannot send back to me.
wow.
Those configuration can be done on network ACL. Do you understand? So these are the kind of differences between them. You understand? So I guess you understand what I mean by that. Okay. So let's see.
Sorry, can I ask?
Is somebody okay? Go ahead, please. Go ahead.
And when you said something like private data centers, yeah. So
Yes,
do you
please.
mean on-prem? Like, do you mean on-prem?
Yes, private data center is usually called on-prem. So on premises. So on your own premises or your organization's premises, you usually have your own data centers. Yes, that's what we mean. Guys, I don't even know what to do right now. I just got a call now that I'm supposed to have a class by 10 p.m. You know, we're not supposed to have class today, but I had so many things I was doing. So, but I guess I'll find a way to explain to my student. But just bear with me, guys, in case we don't stay so long, please. Emma Biner, Sarah. Let me come here. So, AWS launch. It's a private class I'm supposed to have on cyber security. So, Mrs. Precious, Mrs. Yeah, I think I'm correct. Let me see. Yeah, Mrs. Precious, please bear with me, okay? I saw your message on LinkedIn, but if I try to type, was giving me some issues, so I just left it to respond at a later time, and I got carried away with work. Okay, so please bear with me. I'll still respond to you later. Okay. So if you can still hear me, yes, we can. I don't know if we can do that 8 p.m. But let's just see what happens. Okay, I'll let you know if we can do a different time. Okay. Okay, good. Okay, so I want to believe that everybody automatically knows how to create an easy to create what is it called? A VPC, right? So, and when you create a VPC, break down the subnets. So based on what we learned in the previous class, based on the architecture you all did before, right? If you remember what we did in the last class, I even told you guys to try the class work and then use that IP that you calculated with your Excel sheets and create subnets like this. And I know some of you were able to do it. So this is what I want you all to do. Let's put it a step further. Okay. I want you to create 2 subnets. Okay. I think, let me see if it's something I can do quickly. I'll try, but I don't want to rush. That's the reason. Okay. So I wanted us to create 2 subnets. Okay. One of them is a public subnet. The other one is a private subnet. Okay. So, and in the public subnet, it's going to be our web server. In the private subnet, it's going to be our database server. Do you understand? So, yeah, just put a web server here, put a database server here. What I want you to do is create everything from scratch. You understand? Create the VPC from scratch, create the subnets, create the public route table, create the private route table, connect 2 of them together, and let's see what you can do. Is this something doable? Is this something doable?
Yes, it is, but I think we need to write them down. Sorry?
Come again?
I said it is, but I think we should write it down.
Okay.
Can you please come
Madam,
again?
yeah, I will. Madam V, give me a few minutes. I know you want to tell me about the training. Just give me a few minutes again. Okay, so this is what I want us to do, right? So I will create an architecture for it. Okay, so but it's something not far from this one, right? Or yeah, maybe this one. Okay, so either you want to do it like this or you want to do it like this. You understand? Whereby there's a public subnet and there's a private subnet. Okay, so either you want to have two AZs, okay, or you want to have one AZ, and then you have two subnets in it. You'll be the one to decide. So whenever you have in a VPC, right, or in a region that you have three availability zone or six, does not mean you have to use all of them. Okay, take note of that. You don't have to use all of them. Okay, so you decide the number of subnets you want to have. Okay, now, so the task just requires that once you've been able to create your VPC architecture, okay, you've created your stuff and you have a public subnet and a private subnet, right? Now, what I just expect from you to do is in the public subnet, I want you to have a web server running. Okay, so you have a web server running here. So maybe the web server can be can we do it this way? Should I make it an application for you guys? Yeah, let's see how you guys can be creative. Let's see if you can try it. It could be a simple okay, might be too difficult. Maybe I can try it for you guys tomorrow because we have a class tomorrow still. So I wanted to say it should be a Python application running on this web server, and then we have a MySQL running down here. So the application can still connect to this place. Is it possible? Do you guys think you can do it? So this application can be running here and the database can be running here. The goal is to be able to connect to that application running in the private subnet. If you remember, we did something like that in our foundational program when we started. Do you guys still remember? So which one do you think is difficult?
Yeah.
Do you think you want to do the Python
I
that
think
connects to a database, or do you think you want to do just any web server and then maybe just put any database here? The most important thing is that you'll be able to connect into this place. I can show you how to do the connection at a later time. But the most important thing I want you to do is just get the configuration right. Okay. I want you to have a route table. I want you to have a private route table for the private subnet, a public route table for the public subnet. And if you expect the resource here in the private subnet to go to the internet, it means there's going to be a NAT gateway, and you must include it where in your private route table. Does this make sense?
yes, sir. We'll give it a try.
Okay. So if this is doable, if you prefer, I can still document it. So you can I don't want to say expect it
Yes,
before
sir, I
the end
think
of
we
today.
prefer documentation.
Okay, so I won't say expect please don't expect it between now and 12 because I'll still be having a class. In fact, I have another class after this one I'm going to have now. You understand? I don't know why I put all of them together, but I mean, just bear with me, friends, and I will do my best before I go to bed, right? I will tomorrow before I'll try my best before 12 noon tomorrow. I'll try and share the documentation. Okay, I'll try my best and share it. It could be earlier, right? But please just bear with me. Is that okay? Any questions for me, friends? So on the having said that, okay, I'll also try and see if I can get the architecture out for you guys. But if you guys can do the architecture, that will be awesome. You understand? That will be awesome. What is it called? Elastic network interface. Let's see. EC2. Okay, you know what? Network interface. So click on this. So this is what I was talking about, the network interface card. So if you click here, you can see it here. Or if you don't see it here, you can check here under EC2 instance. If you check here, you're going to see it here. This is the network interface card I was telling you about. Okay. So if you click here, you can create your own network interface card. You see that? So you can choose to auto assign an IP address to it. Friends, you understand? That was what I was talking about. So the same thing with elastic IP. So if I come here and type elastic IP, let me see. Did I get the spelling? Elastic IP. Sorry if I'm too fast. So you just come here. Hold on. Yeah. So this is elastic IP address, right? So if you click here and say allocate elastic IP address, right? So it's going to generate that IP from Amazon's pool of IPv4 address. Amazon has some range of IP address. Okay, so you choose the region, and then all you need to do is to come down here and click on allocate. Do you understand? Now, if I click on this allocate, watch what it's going to do. It's going to create an IP for me. Did you see that? This is the IP address it has created for me. So this is a public IP. You understand? Now, but this IP that I have created, okay, or which in AWS term allocate, I have created it, but I have not associated it or attached it to any instance. You understand? So associate this elastic IP address. So if you don't want to click here, you can click here. And okay, so you can come here, select this, and then click on this, and then you see associate. And if you click on associate, it's going to ask you, do you want to associate it to an instance? If yes, you can choose the instance name. Well, I don't have any instance. But if you say no, you want to associate it with a network interface card, then you choose the network interface card. Friends, do you all remember the illustrations? So just try your best and play around this, okay? But please remember to delete it, because even if you don't attach this, you might still be billed, okay? So now that I have allocated it, or I have, what is it called? I have created it, I need to release it, okay? So this IP address, AWS is going to be billing me for it. So whether I assign it on IP address to a PC or not, so the best thing you should do is select this, click here, and say what? Release, okay? Not disable, okay? Just click on release elastic IP address. Click on release elastic, so it's going to release it. And if you notice here, it's no longer here, it's gone, okay?
It's a quick one. How about when you configure your IP? How do you now make that IP a static one or elastic IP? That you
Once
want
you
that
create,
same IP.
once you create this elastic IP, it's static. All you need to do is just attach it to the EC2 instance.
I mean, the one you
Once,
created, the IP you have
that's
personal,
what
the
I'm
one you
saying.
create.
Once you create an EC2 instance, right? Now, and you allocate an IP address. In other words, you create an elastic IP address here, right? The next thing you need to do is to associate it. When you go to associate, it will tell you to choose the instance you want to associate it with. So that instance you created, select it. It's going to map this IP to that instance. So when you go to the location where you see that instance, this IP is what will be showing there. So even if you stop and start the instance, this IP will still be the same thing there. Does that make sense? I hope that answers your question. All right, friends. I don't know if it's my network or you guys can hear me. So that'll be all for today. Please bear with me. We will continue tomorrow by 8:30.
So are we going to build the like for the architecture you want us to do now? Are we going to do it tomorrow still, or you will
It
just
will be
do it?
awesome if you guys can do it. Just a two-tier architecture, right? It's just a two-tier architecture design, right? So the first one is a web server, the second one is a database server, or an application server and a database server, whichever one. When I say application server, I'm talking about maybe a simple Python application that connects to a database. You understand? So either way, but it's a two-tier architecture. So however simple design you want to come up with, just come up with a simple design. Okay. We've done something similar, right? So once you are able to set up something like that, then go ahead and try to implement it. Okay. Use your own unique IPs. Okay. If you want to
But
calculate
if we use
anything you
the
want.
elastic IP, is it not they are going to be lost? So how are we going to show you?
You see?
Should we just take screenshots? Since they're going to be lost for elastic IPs, should we just take
Yeah, of course,
screenshots
you
and
can
leave
just take
them
screenshots,
so
please. Yeah, you can just take screenshots so that it doesn't bill you. The most important thing is that you can talk me through what you did. I really want everybody to own this and understand them. Okay?
so
All right, friends.
thanks.
I know this is very fundamental, and I'm sure this is some people already know how to do this, but I really want us all to understand everything, and it's going to be easier as we get to the deeper waters as we move on. All right. Okay, friends, thank you so much for today. And please expect the recording, expect anything you will get from me later. Okay. Thank you and good night, everybody. I'll reach out to you, Mrs. Precious, later. Okay. All right. Good night, friends. And see you tomorrow.
Bye.
Good night. Stop recording.